My name is Gokhan Kocaoglu, and I'm a sophomore electrical and electronics engineer student at Bilkent University. And this is my EE102 term project. In this project, the main component is the solar panel. And I adjust the position of the solar panel to make the maximum output from the solar panel. I do this by using LDRs, which are light-dependent resistance. These resistances change certain values so that I can adjust the position of a servo motor using the BASYS-3 board and the VHDL language. My design consists of 3 parts. Let's start by explaining the first part. The first part is the most basic part. It is the gathering of the materials and building this wooden piece. This piece consists of 2 parts, as you can see. The first part is the ground part, and the second part is the wooden part that holds the solar panel and the servo together. Here you can see the solar panel can be dispatched and reattached. So it's a quite simple but effective design. The second part is the analog part. This part consists of 2 branches that are parallel. These parallel branches have 2 resistances and 1 LDR, which is light dependent resistor. Firstly, let me show you my analog design behind this solar panel. As you can see, there are the 2 resistances at one branch and the other 2 at the other branch. And if we turn the solar panel, we can see the LDRs, which are placed at the top corner and the bottom corner. The values of these resistances, using LT-Spice, I made a simulation and I determined the resistance values that are sufficient enough for the turning of this solar panel and for the BASYS-3 board. Now let's start with the demonstration of our project. Firstly, I want to begin by simulating a solar cycle, which consists of a sunrise and a sunset. This phone right here will be my sun. As you can see, it has a light, and this represents the sun. And the right hand side is the sunrise. Firstly, I want to show it towards the bottom side. As seen, the solar panel moves towards the light. Now let's simulate a sunrise and a sunset. Let's start from here. As you can see, the solar panel moves towards the sun as the day progresses. Now let's continue with the second step of the simulation, where there are shadows. This thing right here represents the shadow. So let's start by giving the shadow from the left hand side. As you can see, the solar panel moves away from the shadow, thus it maximizes the power output of the solar panel. Now let's try it in the other direction. As you can see, the solar panel moves away from this direction as well. So it's a bi-directional machine. For the third part, I want to show you some buttons and their functions. I want to start with button 1, which makes the solar panel stay in this mode. For instance, if a person wants the solar panel to stay in this mode, despite light being shown anywhere, this mode can be useful. Other than that, we have the button 2, which makes the solar panel stay in the other direction, so it becomes light independent. And if we press both button 1 and button 2 at the same time, now we have a reset button. This button makes the solar panel look vertical. This way, when there is a hurricane or insane amount of rain, the solar panel can stay stable and it maximizes its area, so it is not harmed by the wind. I want to talk about the sensitivity mode that I added later on. This mode is enabled by pressing the button 0, so let me press it now. In this mode, when there is little light, nothing happens, but when there is enough light, we see that the solar panel turns where the light is. So let's start with the representation. Now I'm giving one level of light only. We see that nothing happens. But when I maximize it, we see that the solar panel turns away. But when I turn the sensitivity mode off and add one level of light, we see that the solar panel still turns. So this mode adds sensitivity for removing redundant movement in the panel.